All right. Let's say, so we're going to talk about what inverse variation is. I'm going to use an example. Let's say that you get hired for a job. What type of job should we do? Underwater basket weaving. Perfect. And
this job.
It is.
He's like stupid.
Really?
Yeah.
That just reminded me of something else. We'll talk about it later. But underwater basket weaving. And you sign a contract. The contract is going to take you, let's say it takes you 50 hours. So it takes you 50 hours to complete this contract. But, you sign this contract. Maybe they're going to pay you $1,000 to do this 50 hours worth of work, whatever it is. But let's just say in general, it's going to take you 50 hours to complete your underwater basket weaving. Let's say you do that job by yourself. I'm going to say X is the number of people working, and then Y is going to be the amount of time that it takes you to complete your underwater basket weaving. So if you're working just one person, and it's going to take you then 50 total hours to complete that contract. But you decide, hey, I'm going to work smarter, not harder. So I'm going to invite a friend. So now you got two people that are doing the underwater basket weaving, and we're going to say that they're both the same amount of talent in their underwater basket weaving. So if now you have two people, if one person takes 50 hours, what would you say two people, how many hours should it take?
About 25.
About 25. So now you got two people working on it. Well, that should just be 25 hours each. But you decide to work smarter, not harder again. So maybe you would hire some more employees. You got a $10,000 contract or whatever it is. You can maybe divvy up some of that money, pay some people per hour to help you pay. Let's say you get 5 people to help you, or 4 people plus you. So now you have, if one person takes 50 hours, how long should 5 people take? 10 hours. And lastly, you decide to double that again. Let's say you got 10 people working for you. If you have 10 people working, how long should it take to complete the 50 hours? How much? 5. So what are you noticing as you increase the amount of people working on that job? What's happening to the time it takes you to complete that job? Cutting it way down. Cutting it down almost 95%. You're going from 50 down to 5. That's why some people have employees. You get more contracts filled, less time, and you can figure out how you're paying people, all that kind of stuff. But this would represent an inverse variation. The big thing that you're looking for is as one of your variables increases, as I get more and more people on that job, my time starts to decrease. Now, this is a little bit different than direct variation we looked at in lesson 8. In lesson 8, we looked at as one of your variables increases, the other one is going to increase at the exact same rate. Inverse variation, as one increases, the other is going to decrease. So our very first thing we're going to fill in here is, as X increases, Y is going to decrease. And I'm going to erase this table. It's kind of getting in my way, but you guys kind of got the idea of that. And as X decreases, so as we have less people working on that basket weaving, the time Y is going to increase. Now we get to the product of Y and X. And I'm just going to look back at that table and just look at the first couple of scenarios. So 1 took us 50, 2 people took 25, and then 5 we said will take 10. Well, there's something else unique about an inverse variation. The product of your two variables is going to start to form a pattern. So let's look at what happens when we start multiplying Y and X. 50 times 1 is 50. 25 times 2, 50. 10 times 5, 50. Because how long did the basket weaving take every time? 50 total man hours or person hours. So that's going to give us a constant value. So the product, Y and X, is always going to be a constant. So when you multiply your two variables in the scenario of this inverse variation, you're going to always get a constant value. So when we're starting to decide, do we have an inverse variation, we're deciding as one variable increases, does the other decrease? And then secondly, when we multiply the two variables together, does it equal a constant value that we have? So that would be our inverse variation. So we're going to make a couple notes above this. So our constant, which we're using k to represent that, is y over x, or sorry, y times x. And then our equation for a direct variation is going to be y equals k divided by x. Now that constant is 50. So let's talk about that equation. My constant, the total amount to do the weaving, is going to take 50 hours. To figure out my time, y, I'm just going to divide by how many people I have working for me. So I got 50 divided by the number of people. That's always going to give me my time. So this k right here, this represents that constant of that y and x being multiplied together. So 50 divided by 1 is 50. 50 divided by 2 is 25. 50 divided by 5 is 10. So that's going to be my equation to help me find my time compared to my number of people. Now, direct variation will also be taking a peek at today. Was back in lesson 8. But direct variation, as one of your variables increases, the other increases. As one decreases, the other decreases. So they're going to go up and down proportionally. And then the ratio y divided by x is always going to be constant. So direct variation, we had back in lesson 8. We're looking at our variables are going to increase at the same rate proportionally. Inverse variation, they're kind of going separate, opposite directions. All right. So I need to take and erase that. Is that all right with you guys if I do that? Spencer, you good? Mm-hmm. All right. So heading down, we're going to look at just example 1 and 2 today. So example 1, we're going to use the data shown to determine if it's an inverse variation, and then if so, we're going to find that constant, and then what will y be when the x value is 16. So we'll get to that here in just a second. So the data below represents the equation y equals 8 over x. And I know it's kind of small up there, but you should be able to see it if you have your hard copy notes there. So this would be a job that we want to use the same scenario, a job that takes 8 hours, and then divided by the number of people, we can figure out how many total hours it would take us to do the job. The first thing we're going to look at is the table. You look at your x's. Are the x's increasing or decreasing as you go left to right? Increasing. Now you look at the y's. Are they increasing or decreasing left to right? Decreasing. So it's possible that this could be an inverse variation. The last thing we need to do is check what happens when we multiply y times x. So you do 8 times 1. 8. 4 times 2. 8. 2 times 4. 8. You're getting a constant value every time. So our first question, is it a inverse variation? Yes. And then k, your constant, is always equal to 8. So if we want to use that same example about the total person hours it would take, 8 person hours divided by the number of people is what we're looking at in this one. Part B, what is the value of y when the x value is 16? Well, to do that, we could use that equation. Y equals 8 divided by x. So we put 16 in for x. Y equals 8 divided by 16. Well, 8 doesn't go into 16 evenly, but what fraction would that simplify to? 1/2. So if you have an 8-hour job, you got 16 people working for you, it should take a half hour. So each person is doing their equal weight. Unless you work for the city. You guys ever seen city workers? Yeah. One person working, 8 people watching. Right? They sat in front of my driveway putting tar down for like 4 hours. Just one guy about your guys' age just scooping tar and spreading it out. And then the kid, I was really actually mad. So like the cement gutter, like right at the end of my driveway, he took a scoop of tar and just dumped it. So now I have this big lump of tar, like right at the end of my driveway that I drive over every time I come in. I can't scrape it up. I don't know. Well, and 2 years ago, a snowplow took out my mailbox. That was fun. He even stopped and looked and he realized it and then he kept going. I was home with a sick kid when it happened. And I watched him drive by and just knocked off my mailbox. Snowplow number 11. I remember. I never called him.
You remember?
I do. I remember what the guy looks like. I remember he stopped and I could see him in the mirror, like looking back at my mailbox. Because we have a group of 5, and then it's in our yard, so like we're responsible for it. But yeah, he took out all 5 of them. Nice. Yeah. Middle of winter. I gotta put back together. Yeah, it was not very fun.
Yeah, it was summer.
All right, so example 2, we're going to check again if we have an inverse or direct, and then if so, we're going to find that constant of variation. So we do still have to keep in mind that some of these are direct variations. We got to think about how does that variable act. So x, we're looking at how does the y act compared to the x. So here you're looking at 2, 3, 4, 5. So x is increasing, and then you look at the y. What's y doing? It's decreasing. So now we have a possible inverse variation. We just have to check what's happening when I multiply my 2 variables together. So 2 times 6, 12. 3 times 4, 12. 4 times 3, 12. And then 5 times 2.4, it's like half of 24, which is 12. So we do have that constant value of 12. Once we know that k is equal to 12, that's like your total number of person hours to complete the job. Now we can write our equation. Y equals 12 over x. So it doesn't have to be hours. It could be like maybe you have 12 deliveries to do. Well, if you split those deliveries among 2 people, now it's 6 deliveries each. If you split it among 4 people, now it's 3 deliveries each. Okay? So that would be our equation. Now let's take a look at the next one. Look at the x's, increasing or decreasing? Increasing. How about the y's? Increasing. So they're both increasing. This is possibly direct variations. We got to go back to lesson 8, where our direct variation to find the constant, we're going to take y divided by x, and then our equation is going to be y equals kx. So we check, what is y divided by x? So 6 divided by 3, 2. 8 divided by 4, 2. 10 divided by 5 is 2. 12 divided by 6 is also 2. So possibly direct. The reason I know that I'm dealing with the direct possibly is because as my x's increase, my y's are also increasing. Now I got to check, is that ratio the same? Y over x. Let me get 2 every time. So that tells us that our constant is equal to 2. And secondly, our equation is y equals 2x. So there would be our direct variation. So this goes back to when we were talking about direct variation. Maybe you're buying apples for $2 a pound. So the pounds of apples, 3 pounds of apples cost $6. 4 pounds cost $8. We're going to see that ratio increasing at the exact same rate. Okay? That's all we're looking at for lesson 12. So we do have a little inverse variation only assignment on Delta Math that you can start to look at. But then tomorrow you'll be responsible on your distance day to start looking at lesson 13. And then when you get back to class Tuesday, you're ready to go on that activity. Or land in planes on our Desmos activity. So we'll see how you guys can do with your slope and get that plane to land in at the right angle. So the rest of the time is yours then to work on Delta Math. You can let me know if you have any other questions, need help with anything. I'll come around to check in. But the rest of the time is yours. Does anybody have a copy of that schedule? What time do we go till? I already forgot.
05.
05. So we got about 12 minutes. Yes, Yeah, I'll be right there. Here, I just got to stop this record.